morning, good afternoon, good evening. I'm here to talk to you about WebScale Database Infrastructure Operations Galera Cluster 4. I'm Colin Charles from Galera Cluster. So let's get right into it. First and foremost, who are Codaship? Codaship are the developers and experts of Galera Cluster. Company was established in 2007. There's three founders, all of whom are engineers. So, everyone's fairly technical, from Seppo, the CEO, Timo, the CTO, and Alex, the architect. It follows the services business model of producing open source software. Though, of course, we're, exploring other options besides just open source. Um, and there are thousands of users in various industries, being, e-commerce, betting, gambling, gaming, telco, SaaS, PaaS, IaaS. It's basically very widely used software, well tested in different kinds of applications. And if your application cannot tolerate downtime, data loss, lost transactions, Galera Cluster is the right solution for you. And of course, it is extremely easy to use and get set up. So maybe the biggest gain here is setting up Galera Cluster is very easy. Tuning it for high performance is maybe a little harder. So when it comes to web scale operations, we should ask ourselves, what is high availability and what are you trying to achieve from high availability? We always think of it from a performance and scalability standpoint, in where we tend to measure throughput in transactions per second. We also measure latency in response time, which we measure in percentiles, which you'll find out a little bit more in the next slide. We'll also talk about durability. Because the D in ACID is basically durability. You don't want to lose commit data. And we can do this in multiple ways. Either we have replicas, snapshots, point-in-time recovery, or backups. From the Galera standpoint, everything is sort of a replica. It's an equal replica. Also, we think about clustering. We want to make sure that during clustering, we have good monitoring, we have good recovery, failover, so we don't have any time that service is down. And again, with Galera, these nodes all tend to be fairly equal. Then we also have the ability to do replication. And the replication is basically just ensuring that there is redundancy in your data set. So what is uptime? Many people like to say we have several nines worth of uptime, but if you have 5 nines worth of uptime, it means that you have a max downtime of 5.25 minutes a year. So it's very fashionable to say that that is what you want, but that are you willing to invest in the infrastructure to ensure you get that? So with something like Galera, you have multiple copies of your data. There's a good chance that you could probably have several nines worth of uptime. So there are several types of replication available in the MySQL and MariaDB space. There is asynchronous replication, where you do insert into a primary, and it's very fast. There are no guarantees that any of the secondaries will ever receive such transaction, and you may also have secondary lag. And if you were going to do any kind of failover, so if the primary dies, there is no way for the secondary to take over unless you have some kind of automatic failover framework that promotes a secondary to being the new one. And you want to ensure that it's got the latest transactions, it hasn't lost any transactions. And if there's a secondary lag, there's a good chance that you may also lose transactions. And this is just, far from optimal. But it's very fast, it's the basic, everyone uses it. There's also semi-synchronous replication, where you insert into primary, and then at least one secondary will receive said transaction. So even if you lose the primary, all is well. So this is obviously a little slower because now it has to write to one other node, but that's okay because now you're getting more high availability and you're ensuring that nothing goes wrong. And this is actually how a lot of web scale companies also tend to run. So if you're looking at the likes of Facebook or Google, they all tend to be semi-synchronous based. Then there's also virtually synchronous Galera cluster, where you insert with not just to one node, but when it's time to commit, it actually writes to all the nodes. So you don't actually need any kind of automatic failover framework like you do for the asynchronous and semi-synchronous variants. Because the idea of having to deal with failover is that you can actually you don't actually have to deal with failover, it's already built in. So Galera, following the Galera virtually synchronous model, you can actually write to node 1, node 2, or node 3 in this diagram, and it will all be sort of equivalent. So you will find that all the data is the same. So, does Multimaster solve everything? So, we want read-write queries that are not affected by limited bandwidth with elevated latency over such links. We really never want writes on the master to be visible much later on secondary standbys, because write replication delays definitely are not good for you. We don't want clients at the secondary site losing write access if the wide area network link is disrupted. I use the term wide area network interchangeably with cloud because cloud is basically a wide area network. We also don't want split brain, or two active but separate masters. So we don't want to manage shooting the other node in the head ourselves. And we really ideally want the node divergence automatically resolving once the network returns with no manual repair and resynchronization when you have a multi-primary cluster. And this and more can be provided to you in Galera cluster. So let's look at Multimaster as another tool. It solves many problems but requires some additional design constraints, some of which I'll talk about towards the end. You can deploy it when it solves your problem, definitely do requirements analysis and understand the tools that are available to you. Galera provides for shared nothing storage, so you don't have to use a SAN. Consistency and isolation ensures that your asset is preserved. There's no geographic limitations, so you can run in multiple data centers in, say, Singapore, um, you know, London, and San Francisco. Data conflicts are prevented, so you never have conflicting data sets. You have synchronous commits across all nodes, or as we like to say, virtually synchronous commits, and it's generally transparent to the application overall. So what is Galera Replication? It's a generic replication plugin for database servers. It uses the replication API to interact with the database management system via the WSRep API project, fully open source on GitHub. And WSRep basically stands for writes at replication. The database and Galera plugin must have the same WSRep API version. And I'd be remiss to mention that there's something similar, obviously, called the MySQL group replication, and the form of that is InnoDB cluster as well. So, there are many ways you can have replication API plugins. So when it comes to multi-primary or multi-master replication, it basically looks like one very large database with multiple entry points. Transactions are processed locally until commit time, then replicated across nodes throughout the entire cluster. It is virtually synchronous, such that each transaction is immediately replicated on all nodes at commit, so you don't have any stale secondaries. All nodes are equal. It is obviously multi-primary, so you can read from any or write to any node, and there's automatic transaction conflict detection. There's lots of replication going on, so a copy of the entire dataset is available on all nodes. New nodes can join automatically. It is, of course, InnoDB only when it comes to a Galera cluster. You can't use other fancy storage engines. Data consistency is obviously protected, so you avoid reading stale data, and it also prevents unsafe modifications to data. There's obviously full wide area network support, so nodes can be on a different continent. It can also be end-to-end encrypted, and there's optimized communications with least latency. Can be described as virtually synchronous, as I've already been mentioning for so long. Uh, and it uses quorum-based failure handling, which is again why you have a minimum of 3 nodes as opposed to having 2 nodes. So if one node goes away, 2/3 still makes a quorum to keep the cluster going. It uses optimistic concurrency control to ensure that when you write to say node 1, it applies to node 2 and 3 before it says okay to the client. And all this is basically a core feature of the product by design, because it's not something that has been added on via a third party external piece of software either. And you don't need to do any automatic failovers via framework because it basically just works. That's how it's meant to work. It's totally optimized for the cloud. So the network protocol, as packets are only exchanged over the wide area network at transaction commit time. And topology aware replication means you can also segment stuff. So each transaction is sent to the data center only once. Also, if they're unreliable nodes, so flappy network problems, or nodes keep on getting disconnected, eviction will happen if this happens, and it will not be able to rejoin without manual intervention. And there's no split brain problems when you configure Galera cluster properly. And of course, traffic encryption is key in the cloud, so SSL is available. Also, of course, the reason why we're having this talk is because we want to talk about the new features that are available and the highlights around it. So, we have obviously got streaming replication. We've improved foreign key support. We've built in even more network resiliency. We've got Gtid compatibilities with MariaDB, group commit support in MySQL 8, and also some MariaDB enterprise-only features that I think kind of exciting and or interesting to a lot of you. So streaming replication. It's the base for supporting huge transactions because all nodes currently process write sets in a single memory resident buffer. So in Galera 3, transaction process on the master node until commit time. For large transactions, the write sets will be too large and hard to process. So we've introduced WSRep max, WS size to prevent very large transactions. And when I say large transactions, I'm referring to anything larger than 2 gigabytes in size. Then we introduced something called streaming replication. So you can actually now run transactions of unlimited size in a cluster, and of course, you can still reject large transactions. Now, why would you like to run a transaction that is larger than 2 gigabytes in size to begin with? Maybe you have long-running transactions. Maybe you want to do a load data in file that is very large. So basically, you can actually set WSRep max WS rows or WSRep max WS size to limit the transaction rows to 128 kilobytes and the transaction size up to 1 gigabyte or 2 gigabytes. And we actually have a fairly good guide on how to handle large transactions, including the ability for you to use PT Archiver. We can also definitely do streaming replication because now what we do is we replicate transactions gradually in small fragments while the transaction itself is processing. So before an actual commit happens, Galera is actually replicating small chunks or fragments to other nodes. So when it's you can set the size threshold for said fragment at runtime. It's dynamic, and these replicated fragments are then applied in slave threads, preserving the transaction state in all cluster nodes. So basically, the fragment holds locks in all nodes and cannot be conflicted with later. Streaming replication allows nodes to process write sets greater than 2 gigabytes in size as well. Now, to configure streaming replication, all you need to do is play with these session variables, WSRep transaction fragment unit. So you can just have unit metrics for fragmenting options, again in bytes, rows, and statements, and then WSRep transaction fragment size, which just got threshold units. When the fragments will be replicated, 0 basically means no streaming. Now, naturally, there will be a lot more logging and elevated replication overhead, so streaming replication will cause degraded transaction throughput compared to regular non-streaming replication. The best use case today is to definitely cut large transactions down into size. You can set the fragment size to around 10,000 rows. This is something we've done multiple times, and we think this is about a good example. And of course, applications can also get streaming replication on and off on a need-by-need basis, but you need to change the application. But as I said, this is all dynamic, so it can happen on a per transaction basis. We also added a bunch of new metadata, WSRep tables in the MySQL database. So the 3 new Galera cluster system tables are WSRep cluster, WSRep cluster members, and WSRep streaming log. Yeah. And this is present in, of course, MySQL and MariaDB. I will make clear when something's only present in one or the other. So what do you have in WSRep cluster? It basically shows the current view of the cluster, some identity information, as well as cluster capabilities. Cluster UUID is the unique user identifier of the cluster. View ID corresponds to the status value of the WSRep cluster conf ID. The number of cluster configuration changes which have occurred in the cluster. The view sequence number, on the other hand, corresponds to the Galera sequence number associated with the cluster view. The protocol version is the same value as contained in WSRep protocol version variable. It's the protocol version of the MySQL WSRep or the MariaDB WSRep patch. And lastly, the capabilities column contains the capabilities bit mask provided by the Galera library. It's metadata that will be needed to recover node state during crash recovery. WSRep cluster members is fairly easy. The results of this example, you can see that this cluster is composed of 3 nodes. All the node UUIDs are unique for each node. And then you can also notice that the cluster UUID is the same for all 3 and corresponds to the related value found in WSRep cluster table, as I showed in the example earlier, the previous slide. Each node obviously has a unique name, so Galera 1, Galera 2, Galera 3, and they were named in the configuration file using the WSRep node name parameter. The incoming node address is set to auto for all these nodes, but they can also be set to specific nodes with the WSRep node address or the bind address parameter in each node's configuration file. So this is the MinervaDB CNF. So WSREP streaming log, well worth noting, because it contains the metadata and row events for ongoing streaming transactions. Typically, you will not see any results because it only contains entries for transactions which have streaming replication enabled. We also have introduced WSREP functions, stuff you can build into your application. They are WSREP last seen GTID, which returns the global transaction ID for the last written transaction observed by the client. There's also WSREP last written GTID, which returns the GTID of the last write transaction made by the client. And there's also WSREP sync wait up to GTID, which blocks the client until the node applies and commits the given transaction. So this all requires application changes, but it's also something you can do and utilize to bake in your Galera cluster usage. Also, we have lots of improved foreign key support. So there's right set certification rules optimized now to handle foreign keys. So if you have previously seen false conflicts in certification in your logs, this will now disappear or there will be a tremendous reduction in it. So added bonus. Now, what happens if you have poor network connections? Galera cluster is definitely now a lot more resilient when it comes to handling poor network connections. Basically, there's a feature we call cluster error voting, and it started live in the MariaDB Jira under MDev 17048. A new feature implemented by Alexei. It's a protocol for nodes to decide how the cluster will react to problems in replication. When one or several nodes have an issue to apply an incoming transaction, maybe suspected inconsistency, this new feature will help. So in a 5-node cluster, if 2 nodes fail to apply the transaction, they get removed and a DBA can go in to fix what went wrong so that the nodes can rejoin the cluster. So we're now able to handle irrecoverable errors due to poor network connections a lot better than before. Cluster nodes will leave the cluster as gracefully as possible if it can't recover from the errors, but it will never ever sacrifice data consistency. This is amazing for geo-distributed Galera clusters. We also have group commit. There is support for group commit natively with MySQL 8's binary log. Now, this is obviously fairly important because you want to, because many times people actually also have the binary log turned on for quick recovery sometimes, or even if they want to attach asynchronous secondaries. Their commit time concurrency controls have been reworked such that the commit monitor is released as soon as the commit has been queued for a group commit. So transactions are now committed in groups while still respecting the sequential commit order. So this is like a huge performance boost, I would say, if you're using MySQL 8. Then there's also GTID compatibility inside of MariaDB 10.5. So Galera cluster, of course, can also operate as a secondary to a MariaDB primary server, and the GTID coming from the MariaDB primary is preserved in the Galera cluster because now you'll find that the same GTIDs are available in the binary log file. And the reason behind all of this is, Galera stores GTIDs, global transaction IDs, as UUID sequence number, whereas MariaDB stores it as domain ID, node ID, sequence number. And now Galera cluster uses the same domain and node ID, and the software will only store and show the MariaDB formatted GTID. We've also done some work with MariaDB Enterprise. And the non-blocking DDL is kind of a exciting thing, I would say, because it's similar to total order isolation, which you can use, total order isolation and the RSU methods that are always available. But alter table, create index, drop index, and optimize table are used now for much more efficient locking. It's the NBO option. So TOI is the default. In this mode, DDL statements only need to be executed on a single cluster, and the cluster node will replicate to all cluster nodes. All the cluster nodes will then execute the DDL statement at the same location in the replication stream to ensure consistency. Method is very safe, but it can result in more locking than other modes. RSU, on the other hand, has the DDL statement executing on each cluster node separately. And if the DDL statement causes the table to change in a way that is not backwards compatible for replication purposes, then the mode can lead to replication errors. So therefore, it is only recommended to use this mode if the specific schema change is backward compatible for replication purposes, or if write activity for the specific table has been stopped. And then NBO is where the DDL statement only needs to be executed on a single cluster node, and the cluster will replicate it to all other cluster nodes. All cluster nodes will execute the DDL statement at the same location in the replication stream to ensure consistency. So in that way, it is similar to TOI, but this mode uses a lot more efficient locking for the same operations that the TOI does. And inside of MariaDB, again, enterprise, we have the ability now for you to encrypt the Gcache since MariaDB Enterprise 10.4 onwards. So when you turn on encrypt bin log equals on, uh, not just the IB data, reader log, binary log are encrypted, but also the Gcache is encrypted. Now we also have black box, which is a feature implemented by Pekka, and it's only available in MariaDB Enterprise Server. It allows you to store debug messages in the main memory, the SHM ring buffer. So it helps with troubleshooting a crash server, or even when you're doing cluster testing. We have Galera 4 and MySQL 8 since May 2020. Basically since 8.0.19, comes with WSREP API 26 and the Galera 4.5 library. WSREP is integrated into the release of the MySQL 8 that is shipped, and you can of course download it today. We have of course updated it since then, but since May 2020, you've been able to actually use Galera 4 with MySQL 8. There are of course a few application thoughts that are worth taking a look at. And one of them is you have to make sure that all tables have a primary key. This is extremely important when it comes to Galera cluster. You definitely don't want to have any table without a primary key inside of a Galera cluster. You want to make sure you're only using InnoDB as a storage engine. Make sure you're not using any XA transactions because Galera doesn't support XA. You definitely cannot use locked tables or unlocked tables because again Galera doesn't support that because you don't want to do this in across the cluster. Now, when it comes to this thing called high concurrency hot rows, a lot of people don't set WSREP retry auto commit to have a number. So you should probably set WSREP retry auto commit to maybe say 5. So basically, high concurrency hot rows in the database is where you have a lot of updates in the same exact row. And you need to use something like WSREP retry auto commit to a higher value to ensure that the application knows to expect a delay. Note that 2 transactions writing the same row and committing to separate nodes means only one can successfully commit because it uses optimistic concurrency control, so you'll get an abort or deadlock, and you need to retry this transaction. Also, if you're writing applications that control MariaDB users or MySQL users, DDL statements into that are replicated are statement level, so you have to do things like create user rather than insert directly into the MySQL user table. And of course, schema upgrades like schema changes, either our role schema upgrade or load isolation across the cluster definitely requires some kind of planning, even the non-blocking option that is available inside of MariaDB Enterprise. Rolling upgrades are fully supported, so you can actually migrate an existing WSREP 25 MySQL 573 cluster node by just isolating the node, making one read only. So you have a 2-node cluster for read-write, shutting down the server, upgrading to MySQL 8, start without the WSREP provider, run MySQL upgrade. This is extremely important when you're doing major version upgrades, running MySQL upgrade. Shutting down the server, restarting with WSREP provider, and then allowing read-only access. And then you can update node 2, then you shut down node 1, allow read-write access again, then do node 1 as an upgrade to complete, and then repeat again for node 3. And this is how you end up having a 3-node cluster. It is a bit tedious. There is no automation around this, but it ensures that you can do upgrades without having to do dump restore or having downtime. Monitoring is done fairly simply via things like show global status. Of course, remember that if you do flush status, it resets the status log, so maybe don't do that too often. Galera reports everything via the MySQL or MariaDB server error log. Monitor each node separately for maximum effect. Monitor the health of the network, round trip times, bandwidth, utilization, network links between any 2 segments, or 3 segments if you have 3 data centers. One way to try MariaDB Enterprise is to get on the free MariaDB SkySQL train. That's $500 credit. You can play around with 10.5 if you like. What's next? XA transaction support is coming. It's a feature implemented by 2 of our developers, and we wanted here for Galera cluster to operate as a resource manager in an XA infrastructure. There is a transaction coordinator where Galera cluster can operate as an XA resource manager, so the Galera cluster should be able to prepare or roll back or commit a transaction. XA transactions are supported thanks to the implementation of streaming replication, which is a foundation for it. The work has been ready since MariaDB 10.4, was not accepted in the main tree, and lightly targeted again for 10.5, but missed the train. So basically, it will definitely be in MariaDB Server 10.6. There is also, on top of that, we can build the idea of a sharding cluster via Spider. So MariaDB 10.6 includes XA transaction support testing and documentation to make Spider cluster work as well. So Spider is a storage engine that is part of MariaDB that also depends on XA. And then this helps MariaDB become a sharding cluster. So you have extreme write scalability that could come from such a setup. Now, the disadvantage of sharding cluster being built via Spider is Spider does not work with MySQL any longer. So this will be another MariaDB community and enterprise feature that will be currently basically missing from the MySQL world. And we will work, and based on needs, we will definitely want to work on sharding cluster for MySQL as well. There's also dynamic SSL TLS implementation. We want to make it much easier for the end user to turn on SSL or TLS because most of our Galera cluster users are running in the cloud. And then of course we'll do further optimizations for streaming replication because that's just something we have to do to make things better, faster, and let people use it. So quick comparisons with other variants of Galera 4. So MariaDB Server has had two releases now, 10.4 and 10.5. With Galera 4 since 2019 and 2020. Pacona HDB cluster actually did make a release of Galera 4 based on the MariaDB codebase at the end of April 2020. And Codeship, us, we made Galera 4 with MySQL 8 May 2020, so about a month after Pacona. Of course, we have to do some quick comparisons with other variants naturally. So MariaDB Server 10.4 includes use of backup locks, which you can use with Maria Backup, so you can use SSD for lightweight locks. Pacona HDB Cluster 8, of course, includes all the features you're familiar with Pacona Server, but it also comes in addition with things like proxy SQL, a Kubernetes operator, encryption plugin thanks to Vault, PXE encrypt cluster traffic is enabled by default, so that's something that you also see that we were thinking about wanting to do, but there, no unauthorized SSDs will then occur, and MySQL upgrade because data dictionary is versioned in addition to MySQL. Things like Gcache recovery is turned on by default, including PC recovery. These are all configuration file options, just meant to make it easier. And of course, PXE includes extra backup shipped by default. But overall, in summary, the developers of Galera cluster are Codeship. The most developers of Galera cluster are at Codeship. And of course, who knows the code better than anyone else? It's basically again Codeship. So who decides the roadmap of Galera cluster? It's back again to Codeship. And our main partner with MariaDB Corporation, we also listen very closely to the community. We've also recently dabbled with doing a GUI tool, a GUI deployment tool, which you can find at galeracluster.com. So it's called Galera Manager. We highly recommend you take a gander at it. I could obviously do a demo if that's required. But yeah, if you have any questions, please do shoot me an email at colin.charles@galeracluster.com or we'll hear you on Slack. Thank you very much.
Thank you, Colin Charles, for registering for MinervaDB Athena 2020 and speaking in the event. Great, man. Happy to see you in Athena 2020. Welcome.
Thank you very much for the invite, Shiv. It's great to be here.
All right. I tell you, when we were almost towards the closure of the talk, choosing the talk for the event, most of the committee members came front and like, hey, something, Shiv, there are interesting talks happening on MySQL performances. MariaDB talks are happening. There are PostgreSQL talks, and there are also Linux SRE talks. Can we miss Galera cluster talks? We can't. The reason because it's like, one, when you're talking about data reliability, the first thing comes on both on MySQL and MariaDB is like, hey, how we can evaluate Galera cluster if you're building a zero data loss replication infrastructure. And so that, because I didn't see any submissions, so I thought I'd directly reach your team, and you guys have been so quick and fast, so thank you for that. I was going through your talk. It is like Galera cluster 4. would like to know about, we'll be very curious about what are the most compelling reasons for a production infrastructure team to migrate to Galera Cluster 4. What do you see is looking great on the reliability perspective on Galera Cluster 4 compared to the previous releases? I'd like to know about.
Yeah, yeah. So again, yeah, thank you very much for reaching out. I guess very importantly, with regards to Galera Cluster 4, the major feature we brought out was streaming replication. And that basically means that you can now have very large transactions greater than 2 GB in size be replicated across Galera nodes in chunks. And it could be chunked up via rows, which you can configure at runtime. But that's not the only important feature that we came up with that would benefit lots of people in terms of an upgrade. We also have, write and replication functions that you could actually input into your application to wait for cluster status. We've also added a new monitoring available inside of the MySQL tables. We've expanded such that if you're going to have a flappy network or need more reliability in the network, the algorithms have been hardened up tremendously. I think the biggest gain you get from Galera 4 is that it's actually comes with MySQL 8 as opposed to MySQL 5.7 and Galera 3. And this is also true even in the Pacona XGB cluster 8 space, which also brings you Galera 4. And for a while, actually, to be fair, MariaDB 10.4 has already had Galera 4. So MariaDB 10.4 came out middle of last year. 10.5 is out, middle of this year, and it's also available in the SkySQL cloud. So yeah, while MariaDB gets Galera 4 first, and if you end up using the SkySQL cloud, you'll get to even do things like get full-on encryption. So the Gcache is encrypted as well, as opposed to just the all the other tables and files. So yeah, we definitely see a lot of benefit for one to upgrade to Galera 4. And I think the biggest reason is also the fact that you're getting MySQL 8. So MySQL 5.5 is clearly getting old, if not deprecated. And then there's 5.6, which is also fairly old. So having a 5.7 for a very long time, 8.0 is a clear benefit. So you're getting all the benefits of 8 JSON. The fact that it's also integrated with the MySQL group commits, so you're getting more and better integration with InnoDB. You're getting a lot of reasonably good features with 8. So I think upgrading is not just to get new features, but also to get stability, to also get performance improvements, and to be more reliable. And obviously, you get more monitoring options as well.
Oh yes, like when you said about the monitoring options, I was about to ask you that as you become more and more feature rich, when you talk to me about the streaming replication, that means like we are talking about the I don't say it as a compliant, but then always it is about if I'm a database reliability engineer who is building a zero data loss database infrastructure on a synchronous replication using Galera cluster, I will always have a concern about, look, there is going to be latency when there is going to be a distance, the physical distance between my server goes high. Now, when you tell to me that, hey, something, we are going to ship streaming replication that's going to be more high performance replication compared to the previous replication what Galera cluster was talking about. Now, as you rightly said, one, it is a MySQL 8, like write set replication API infrastructure from Galera cluster. Two is about the streaming replication integrated to that. Do you have any good news for somebody who has? I'm not talking about multi-city Galera cluster, but then about multi-DC with a significant distance in the same city. Like, so. Do you see?
Yeah. So with a greater latency is basically what you're going for. And yeah, Galera even in the later releases of 3 had a more optimized network protocol for far latencies, as well as nodes that were a bit flappy. So even if you had multiple data centers, it didn't write to every node, for example, it was writing to elected nodes. Now obviously the algorithms have improved a little bit, and we expect that the next release will have even more improvements. Streaming replication, I think, was a very good base for what is coming next. So obviously, if you use streaming replication, we'll also tell you that there will be obviously some kind of performance hit compared to regular replication because it's now chunking everything up. But at the same
mm,
time, this is the very important base for what comes next. And
mm,
what comes next is also obviously things like support for XA and also obviously improved performance. So I'd say migrating to 4 and using my MySQL 8 is a good stepping stone to where you
mm,
go next. And obviously we support upgrades going up
mm,
from say 3 to 4, and 4 to what comes next. But
mm,
we don't go backwards. So yeah, definitely you'll see improvements even
mm.
when it is more latent, so to speak.
Thank you. So this is something I was talking this on one of the user conferences hosted in Jakarta in Indonesia 2 months back. This is again a virtual conference, right?
Mhm.
The concern was like it was a concern from the conflict detection in MariaDB when you have a multi-write infrastructure. Though MariaDB um, it was a MariaDB plus Galera cluster. So though it is like internally from MariaDB, they always recommend like multi-write is something which you have to be cautious about. They
Mhm.
don't discourage that, but then they say like you should be cautious about. Whereas Galera cluster say that it's okay you do multi-write provided you know how multi-write works. It's fair for you. But when I was going through the Galera cluster for release notes, I could read somewhere that there is more responsive conflict detection is coming up in Galera cluster 4. Do you
Yeah.
want to share with us some high-level story of that? That'll be great.
Yeah, we definitely have a lot more responsive conflict detection. We also, remove things like erroneous
Mm,
foreign key conflicts that used to appear in your logs. So sometimes they were just appearing in your error logs, but they weren't actually really a problem. So we've
mm,
actually fixed some of that stuff. So if you're using
mm,
foreign keys and you're finding lots of problems, you'd see that. And also conflict detection algorithmically has improved.
mm,
Internally, there's been some changes to the way these structures are
mm,
handled.
mm,
And yeah, of course, yes, multi-rights are obviously supported if you know what you're doing. But at the same
mm,
time, if you have a proxy in front, be it MaxScale or Proxy
mm,
SQL or HA
mm,
proxy, one of,
mm,
one of these could totally help you if you're starting to see a lot of conflicting
mm,
issues. Of course, the
mm,
the other very basic one is the writes and replication retry auto comment, which many people don't set. So
mm.
I
Yes.
guess the thing about Galera is it's a bit of tuning. Setting it up
Mm,
is really easy. It takes like 5 minutes to set up a 3-node Galera cluster, but
mhm,
making it tuned for actually running takes a little bit more effort. I think that's what a lot of people tend to miss out on.
mm, mm. You're right. So that takes me to the last and the final question of this conversation. Like, uh, as an evangelist and strong community advocate of Galera cluster, what could be the top 3 recommendation you say when somebody's setting up Galera cluster for scale? I'm just not looking at from a performance perspective, but then from a
Mhm.
scale perspective. Like when I have more number of nodes, I will not be disappointed on deeper latency issues. So do you have something like 3 things if I do that right at a scale, Galera cluster will do good for you?
Yeah, I think the first thing, even though won't be to scale, but to get you started is to actually turn on logging. Like make sure you have verbose
Mm-hmm,
logging turned on. It's off by default.
mm-hmm,
Then the next thing to do is obviously configure your Gcache page size relatively well, because
mm-hmm,
I've seen so many installations where there is no configuration and the default configuration is 128 megabytes. So pretty
mm-hmm,
much every time a node goes away, you end up
mm-hmm,
having a full-on state snapshot transfer at SST, right? So and you really want IST, which is an
mm-hmm,
incremental
mm-hmm,
snapshot transfer. And
mm-hmm,
then so that's basically two things. And then the other one is the easiest thing is to make sure you've got retry auto commit turned on. And I guess the other added bonus is if you really are wanting to scale, you got to make sure you have access to also potentially change the application to ensure
mm-hmm,
you're not hitting things like hot rows, for example.
mm-hmm,
I think that's very common. But we also see like well, now we've gone way past 3, but we also see very commonly like people say, hey, we've got all these
mm-hmm,
DB tables without primary keys, and
mm-hmm,
you know Galera, it works, right? Until it stops
Mm,
working when you need to, run a
mm,
delete, for example,
mm, mm,
or things are out of order. So there are obviously some limitations that we already list. I mean, not we only, but everyone lists. And Percona has a strict mode for this. MariaDB has a forced DB
mm,
primary key mode for this. It's just that we just need to turn on these options to make it even stricter, to
mm.
make sure you enjoy using and scaling with Galera cluster, so
Thank
you
you.
don't end up making mistakes. Yeah.
I mean, this. I tell you. How coincident is this? So I was talking to one of our core committee members, right? Do you end up in overlogging Galera for more data, and that becomes a bottleneck of extra writes happening there, right? And when you say this, right, like uh, when you know what you are doing, or when you are configuring Galera purely for reliability, right?
Mhm.
Then then you are discounting the fact that like one, the conflict detection is taken care. Two is that you will not have a conflicting write which is going to happen on the node, and you end up in shooting both the nodes. The third one is
Mhm.
about how do you tune Galera within Galera, not from Percona or from MariaDB for the
Mhm.
performance. Within Galera, when you tune, you benefit more. Interesting, man.
Yeah, definitely tune Galera. Like, don't only tune your server. Most people just have a very basic
Very true.
Galera.cnf, or yeah, it's just here's three nodes, go get started. And Galera will get started. That's a thing.
Yeah, then Galera is very tolerant. So this is something which is my personal observation. Galera is highly tolerant. That said, if you don't handle Galera properly, then Galera knows how to keep you safe. So
Yeah,
I
yeah.
don't
So
call it that. Yeah,
it's a
yeah. Go
trade-off
ahead.
between ease of use, which is the ease of installation, and also the ease of actually getting going. And yeah, I think documentation is something we can all improve on. So it's there's a hodgepodge of documentation between Galera and MariaDB, as well as Percona.
Mm,
And even I regularly find some deprecated variable that is in, say, one variant of the documentation. But that's, I guess, the beauty of uh, the community adopting the solution, is that everyone doesn't keep necessarily track, and then we can all just email each other and say, please, fix this documentation error.
this is my personal observation. Now that we see Colin in a Galera cluster infrastructure, right? I mean, ecosystem, not infrastructure, ecosystem, right? We have seen you in in a MySQL ABA big time. We have seen you very active in MariaDB. You have seen you very active in Percona, right? Wherever you
Mhm.
have your presence is there, there is always there'll be a greater level of access to the clarity, right? I don't call any documentation perfect documentation, but the clarity gets wider actually. I'm sure not just me. There'll be a lot of people looking forward to that, man. Colin is there. No, we get more data out from the Galera cluster. Happy to have you there.
Thank you very much for the nice words, Shiv.
All right. These are all something from me in this conference, Colin. Thanks again from MinervaDB Athena conference committee for coming in on a very quick short notice, and submitting your talk, and giving us more insights on making Galera cluster infrastructure operations more successful for respective business. Looking forward to seeing you soon, and wishing you a very happy Merry Christmas in advance, and a great 2021. More happy, more healthy, where we all can keep moving around.
Likewise, Shiv. A very early Christmas, good New Year. It's going to be another great year, I'm sure, for all of us in the open source database ecosystem. Thank you.
Thank you so much, Colin.